long-time contributor to FOSS4G. Welcome, Tom.
Thank you very much. Great. So thank you for attending this morning. I will walk us through the OGC CITE Runner, which is a convenience runner written in Python for OGC compliance testing. So the project is Ricardo from Portugal and myself. And Ricardo couldn't make it with us, so I'm presenting on our behalf. So basically, I will talk a little bit about the idea of OGC standards and compliance and certification. I'll talk about the CITE engine or the TeamEngine that OGC offers to do compliance testing, and then I will talk about OGC CITE Runner, which is our light wrapper around all of that to make things easier, as well as some future work. So in terms of OGC standards, there are a number of considerations for being compliant. Standing up an OGC service does not mean you're compliant. Writing software for an OGC standard does not mean you're compliant. It means you implement it. So there's many different levels. To become certified, you have to pass all of the compliance testing that OGC makes available. And if you don't want to go that far, there is an uncertified route where you can list your product, your software product on the OGC website, whether it's a decoder, an encoder, a server, a client that supports a given standard, and you can register it as implementing. But it is not OGC compliant per se, and you do not have the right to provide that stamp of approval on your website. The other nuance with compliance testing is that compliance testing for OGC compliance testing is per standard. So each standard has their own executable test suite and definitions of what they deem compliant. So that's on the OGC side, and they have one test suite per standard. And then on the software product side, it's each and every version of your software. So if you have 10 versions of your software, you need to make sure all those 10 versions, you want to make sure all those 10 versions are compliant with the standard. So when looking up the OGC website for compliant software, it shows the version of the actual software. So it could end up being a lot of work to continuously test all these things across different versions. CITE itself stands for Compliance and Interoperability Testing and Evaluation. This is a long-standing program from OGC. We wanted to have this in place. It's been in place for a very long time, decades in fact, to ensure compliance and compatibility. Compliance is especially important for trust in a piece of software, as well as things like procurement. You could write in your procurement, if you're an organization that's procuring software, you could say we only want OGC compliant software. So software products also have an initiative and a goal to be OGC compliant, which also helps them on things like bidding on contracts and so on. So OGC has this CITE program and a repository of conformance tests, one per specification. So Web Map Service has an executable test suite. Web Feature Service has one. OGC API Records will have one. OGC API Features has one. You get the idea. It's one per standard. The CITE tests themselves from OGC are all open, on freely available, free and open source on GitHub. And the actual runner, the actual framework that they all fall under is something called Test Evaluation and Measurement, or TeamEngine. That's a FOSS project that has nothing to do with OGC, but OGC used that framework, that Java framework, and from there, they're writing one GitHub repository per standard. So there's a lot of the baseline things that the TeamEngine does, and then in Java, and then each specification writes their conformance tests against that. How do you run CITE? Has anybody ever tried to run OGC compliance tests on the website? No? Okay. I'm the only one that has the scars. So typically you run it as an interactive web service, so you have to go online and you have to click, and type in the URL and some other parameters depending on the specification. There are some nuances between the specifications on what your inputs need to be, but primarily it's a URL or an endpoint, and then from there the endpoint can be further interrogated by the compliance test. For the first generation standards such as WMS and WFS and so on, you used to have to stand up your own demo server and the actual test data that is provided by OGC. Why is that important? Because, for example, if you wanted to do testing against WMS, where you actually wanted to test pixel values coming from a WMS request, a get map request, it's super important that you have data which is fixed from the testing perspective. So you typically go to site.opengeospatial.org or site.ogc.org these days, /TeamEngine, and you can fill in everything you need to do, and you run TeamEngine against your service. It will give you a long report with red, yellow, green, and you can dig down and find out things that passed, things that did not pass, things that were skipped, just the same. In recent years, so this is an online service from OGC. In recent years, the good news is OGC is also offering Docker setups for each of these. So you can actually run these compliant tests by running CITE on your own server, on your own laptop, for example, which is really great for local debugging, especially if you have a piece of software on your laptop and you don't necessarily have the infrastructure to stand it up on a public URL. So this is really, really useful that Docker support is increasingly being added to the CITE tests. So OGC has a long-standing compliance program. There is a CITE TeamEngine that they run to help you evaluate your software, whether it's OGC compliant or not. Why do we need anything more than that? So speaking from experience on my experience on a number of projects in the geospatial Python realm, which deal with servers such as PyCSW, PyGeo API, map server, and so on, we wanted to have a way where we could have an automated way to test all this. Why is that important? Because maybe I want to test all of the OGC compliance on a pull request in my of my software, or run it on a schedule every day to make sure things are compliant. So this CI/CD approach to doing compliance testing, which would help automate things. In fact, for PyCSW, what we did was we ran the CITE tests against the CSW tests, and in the back we were saving all the requests and responses that CITE was making, and we stored those all locally as test files for regression testing. Works great, but it was just a lot of work to put that all together. So you want to be able to do that without storing these things in your own repository. You want to be able to stand something up and run it and have it work in a more automated fashion as part of a pipeline. The other value proposition is this would work for any software, not just Python software. Even though this is written in Python, you can run this against your Geo server, you can run this against your QGIS server, you can even run this against your commercial server, which says that it is compliant to a standard. The one part that I forgot to mention is the newer OGC standards, such as the OGC API standards, typically do not include test data, so it's a lot easier for you to evaluate your demo server, for example, without actually putting that test data there anymore. So now, with that, we introduced OGC CITE Runner, which is a test runner for OGC test suites, and it's an abstraction on top of the way you would interact with OGC CITE and TeamEngine. It allows for CI/CD type integration, so you can put this as a GitHub action. You can run this on the command line just the same, and you can handle things that way. And it's great because this lowers the developer barrier to site testing. We are in a time where doing things on an interactive website is great, but when you have projects with so many commits and a lot of people working on things and just a fast-moving pace of software development, it behooves us to have a more low barrier way to put this all forward. So things like working with a command line and putting this in your GitHub action or pipeline. This is not only for GitHub, but you can put this in something like GitLab, for example, and so on. So really feeding this pipeline approach to doing site testing. for any server that is looking for compliance testing. So, okay, that mermaid diagram is a little bit broken, but you can see that we have the test suites. So the test suites are one per standard. So we would have a suite for WMS, a suite for OGC API maps, suite for OGC API features. You get the idea. You would have the application tested. Typically, we call this the implementation under test. So this is your endpoint or your URL. You send that to TeamEngine, and TeamEngine provides you a report. And here we would have seen a few interactions here, which basically says the site runner will hide all that for you and just give you fancy command line console type output as you need it. And how do we get this actually going? So we have a quick start here as part of the presentation. So let's walk through some of the quick start. First, I mentioned that you can do a lot of the ETS executable test suites in OGC through Docker now. So the first thing we can do is start up a local instance of TeamEngine itself. And you would run those steps, and you would go to localhost 9080, and then you would have a local version of OGC TeamEngine running for you. Then you can install OGC CITE Runner. It's available on the Python package index. So you would do a pipx install or a pip3 install OGC CITE Runner, just the same. And then you would have it installed in your environment. So this is pretty typical if you're familiar with Python. You would point to an application to be tested. For example, this is the demo server we have for PyGeo API, but it could be any server that you may have in your environment that you want to test. And then you would run this on the command line. So basically, OGC CITE Runner is a command line tool, and you are saying execute the test suite, and you have to provide the URL to the TeamEngine service, the test suite that you want to test, as well as the implementation under test. So here I'm saying I want to test demo.pygeoapi.io/master against OGC API features tests for OGC using my local TeamEngine. And that's that. In the same way, obviously you can swap out the URL to another OGC service that you wanted to test. You can use TeamEngine directly, so you can say site.opengeospatial/TeamEngine. That kind of thing. So you can swap these in and out, and you can run these accordingly. The quick start here is getting everything running locally on Docker to get you up and running. So what happens in an execution? What happens is OGC CITE Runner performs these steps behind the scenes. So it asks TeamEngine to run the specific test suite. In this case, OGC API features version 1. Then from there, TeamEngine actually runs all those tests back and forth. And if you're looking at your server and you're running your server logs, you'll see a number of different HTTP requests come through. Keep in mind, you don't want to run this against an operational endpoint or anything like that. You might get some nasty emails from sysadmin. So I just have to put that in there. So basically, it runs the TeamEngine tests against your server as if in the same way as if you would have gone to the website and done everything interactively. It parses the evaluation and report language, which is an XML dialect, and then it makes a fancy output on your console or your command line or in your GitHub action result. So some additional features. Again, you can get output in the console. So this is great for quick inspection. It also serializes things to JSON if you want something a little bit more machine readable coming out of OGC CITE Runner, so that you can additionally parse that and deal with that in a machine readable way. It can give you markdown if you wish, with checkboxes and X's and so on, or it will just give you the raw XML format if you already have an URL parser with you. So a number of different options for output. Default is on the standard out. So another thing that you can do is, in addition to executing the test suite, is you can parse the result. So maybe you have a result on disk and you want to parse it, you can send this along just the same. So how would we actually do that in terms of raw format? Output, you would say, execute the test suite, and you want the result to go into execution result.xml. That just redirects the output on the screen, the raw output on the console to the XML file, and then you can actually parse the result. This is valuable, again, if maybe you're getting the results from somewhere else and you still want to parse them. We were able to split out that functionality so that that both are available to you. Here's an example in JSON. So you can parse the result and you can say output format equals JSON of the execution result, and you can pipe it through something like JQ if you wanted to do some machine handling of the output on the command line. So when you run OGC CITE Runner, you also have an output report, obviously, which gives you a summary by default, and then it'll tell you how many tests failed, how many passed, and how many were skipped. You can also toggle the sections on and off with skipped or with failed, with passed. Maybe you only want to see failures, and you don't want to see anything that's passed because it's passed and you're confident enough. So there's switches on the command line to be able to do that. Next up is GitHub Actions. So suppose you want to run this on GitHub itself in your workflow. So you can do this by adding this to your workflow file. So basically, what we see here, where we see the line that says uses, that basically is pointing to a GitHub action that's defined at that repository, and you can see it's pinned to a specific version. So for those of you, is anybody familiar with GitHub Actions? Right, so this is classic conventional GitHub Actions type of syntax, and we are basically doing what we were doing on the CLI with GitHub Actions just the same. So here we can see basically the CLI arguments and using the CITE Runner as a GitHub action. This is really powerful when you do pull requests against your software and you want to test them all the time against compliance. And what that gives you is once you see the workflow output, you would be able to see the console. You can adjust the outputs in the workflow definition. In terms of if you want console output or markdown output, or JSON, you get the idea. And finally, in terms of future work, so what we have running so far works. We have a minimum viable product that is at version 0.3.1. It will work against any of the OGC compliance tests. So it is designed to work against the first generation OGC standards, the current OGC API standards, and so on. So some future work is we want to publish this action to the marketplace, the GitHub marketplace. It's not currently there. That doesn't mean you cannot use it in your workflow, in your CI just the same, but we do want to have that as a milestone to get it onto the GitHub marketplace proper. We want to add an option to allow managing TeamEngine execution internally. And finally, as part of this effort and beyond, we want to start socializing this a little bit more. Because even though this is a Python project, this would apply for any project which does OGC standards and wants compliance. So this would mean working with the various, socializing this with various other FOSS4G or OGC compliant servers, whether they're free and open source or whether they're commercial. And we want to have this socialized as well at OGC. So at some point we'll be presenting this at OGC as a low barrier way to do site testing via the CLI or GitHub Actions and beyond. So that's most of the presentation, or if not all of it. Thank you for your time. I hope this was valuable, and please keep your eye on the project as we continue to grow over time. Thank you.
Thank you, Tom. Any questions? Yes.
I guess this one is just a minor one. Slide 17, Tom, please.
17.
Maybe I just didn't get it. 17 or 16,
Is that
yeah,
17?
probably. There's sample code there. So I see a couple that the output format is JSON, but the extension for the file is XML. Is that the right one?
Yeah, basically,
Okay.
good question. Basically, you are asking OGC CITE Runner to parse this XML file into JSON.
Okay.
Basically converting it from XML to JSON, and then we're piping it to JQ, which is looking for pass.
Okay.
So the pass would be in the output JSON.
Okay, sounds good. The other one is more of a conceptual, so kind of new here. So what if you got multiple standards implemented in certain endpoint? So how do you decide, you have to kind of test it pointing to several, standards?
Okay, good question. So if I can just replay that, how do we detect, what if you are implementing multiple standards at a single endpoint? How do we sort that out? That's a good question. Where are we? So basically, this, for example, demo.python-api.io/master is implementing all of the OGC API standards from that single endpoint. So from there, you will find records, features, tiles, coverages, EDR, everything, all those things. But the differentiator here is that, yes, we have this landing page, but we want to test it against OGC API features. So basically, it goes into OGC API features mode of testing. This could have been OGC API tiles, and then it knows how to look for specific things based on the standard from the server.
And my last one, to give others time to ask, are there any kind of considerations in terms of you got more kind of restrictive implementations, you get proxies and other, security features in place in the back end? Would that be affecting, these test suites not to work properly?
It probably would affect it. I mean, you would need to ensure that HTTP proxy environment variables are set accordingly. From this tool's perspective, they don't handle, proxy is relatively pass-through.
Okay.
And things like security, authorization, and authentication are another matter. If you have use cases from that perspective, definitely send them on through, because we do want to build on that.
Okay, awesome. Thank you, Tom.
Thanks.
Any further questions? Yeah. All right. Well, let's thank Tom for his time.
Thank you.
We have